This example is the coordinate one. So I keep doing multiple examples because there's different types. I can give you an equation. I can give you a graph, and you do the inverse. I can give you the equation, and you flip it around. What if I just give you a list of coordinates again? So this is where we started the lesson, right? So a little bit where we started. So remember, when I gave you the coordinates, you're just flipping them, right? So that's this idea. You're just flipping the x and the y. So we're back to that again. So one more time. We have all of these things here. The inverse is everything flipped. So let's just go ahead. If I want the inverse at 4, I can rewrite it and say, okay, the inverse, I'm going to use the notation because you're telling me it's a function, so I even can guess it's going to be a matching set. And you're going to rewrite it. So you're going to go, okay, this is going to be 2, 3, 4, negative 1, negative 2, 0, 3, 4, I ran out of room, sorry, 6, 11, and negative 8, 6, like that. So the inverse is every single one of those coordinates flipped around. X switches with y, y switches with x. So I'm asking you, where's the inverse at 4? Right, so we learned this at the beginning of the chapter. That means when x is 4. When x is 4, so go to your inverse. When x is 4, so we want f at 4, or the inverse at 4, it's here. The inverse at 4 is, and it's just negative 1. Is that all right? Yep, try the next one. I know, sometimes I end with an easier question because it's like, oh, okay, we're tired, our brains are getting a little bit, so mushed up. So try the next one, the next two. See if you can do B and C. So for B, we're looking for the inverse when x is 3. So the inverse when x is 3 is 4. Yay, 4. Okay. Now, I want the inverse. Remember, when it's equal to it, so this part here, that means that's actually the y value, right? So in your head, you're going, it equals to it, so that's the answer, which is the y value. So I want the y value, which is here. Only one answer, right? Is there double answers anywhere? Next is 4? No, because it should be single, right? So it's a function. So when the y value is 6, it's right there. So then x equals, so you're looking for the x. So therefore, x equals negative 8. Does that make sense? Okay. You don't have to, let me just point out, you don't have to rewrite it if you don't want to. Some people go, I just picture it in my head that it's opposite. So, yeah. So if you can do it that way, you don't have to rewrite it, but if it helps you, rewrite it, right? Because some people are like, I can't picture it, my eyes are going buggy. So I'm like, okay, I'll just rewrite it. But if you don't want to, you can say, if the inverse at 4, the x is 4, I picture the y, so I go find the y here, and they find the y at 4 and go back. Sometimes that's like too much where your head's like, I can't remember which way I'm heading, so rewrite it if it helps you, okay? But you don't have to if you can do it backwards. Yes? You don't need the therefore, no. So just tell me that you found the x, though. Don't put equals negative 8 because that won't make sense, so put x equals. So as long as you got the x equals, no therefore, Just put the x equals, okay? And then one more time, going back to what we remembered from before, don't purge what we know, this is just the regular function. So on the test, we usually have inverse and regular functions questions in the same question, right? Like I'm not going to ask just inverse in one, I'll have it A, B, C, oh look. So this one, regular, not inverse. So just go to your regular function, right? Go to your regular function and grab the 4 when that is y, right? So that's regular function, not the inverse. Okay, so regular function, when y is 4, that would be negative 1. So x equals, you don't have to do the therefore, negative 1. Okay, so just because it'll be mixed up on the test, we'll have both types of questions usually in one. Okay, one last type. Again, just so you can, when you do your homework, you've got a little bit to go with. Here, I gave you the equation, right? So this one's back to the equation ones. We've done graph ones, we've done equation ones, we've done coordinate ones, back to the equation one again. There's no grid, so that's a hint that you don't have to graph it. So I gave you the equation. I want you to find the inverse at 5. Inverse at 5. There are 2 ways you can do it, right? So you can go ahead and just find the inverse equation. So let's try that one first, because most people are like, so you mean find the inverse? Yes. So let's try that. There's 2 ways. So I'm going to do an OR scenario. Okay, so I'm going to do 2 different answers, one and the other. Both of them are wonderful and good, but we're going to try both. So the first method is going to be, I'm going to just find the inverse. Okay, so for this method, I'm going to find the inverse of g of x. So the steps that I was showing you before, finding the equation. Okay, so this is, I'm going to do step 1. So start at step 1. Again, you don't have to number it. Step 1 is switch it. So y equals 3x, not switch it, sorry, switch the y. This one here, step 1. Step 2 is the switch of the x and the y. So we're going to go x goes here, y goes there. And step 3 is solve. Are we okay with this? Getting a little easier? Yeah. So I'm hoping by the end of the lesson you're like, oh, okay, I can start my homework. We're good. Okay, so isolate. So bring the 4 over, x plus 4. Divide both sides by 3. I don't care which way you divide, all over or each one. Both are wonderful. Step 4, decide. Match it with step 1. Is it still a function? Yes, because I gave you the hint that we've aligned to a line. So, and we're going to use that inverse notation. So you go therefore. You don't have to do the therefore, but this one, inverse of g at x equals. Okay, so the step, method 1 is to go ahead, find the equation, which is what we've been doing, right? So if you're getting comfortable with that, that's good. And then, is that okay for that part? Okay. Then answer your question. So g at 5 means you're just subbing in the 5 for x. Right? So wherever you see the x, you're subbing in the 5. So we go 5 plus 4 over 3, 9 over 3. So it's 3. Right? So it's a bit of work, right? Because they're making you do a double question for that. It's not bad, just a little work. Wait. Okay, or. My or scenario is, ooh, that line's up. Oogly. Okay, my or scenario is, you know how it switches x and y, right? And we did this one up here with the x and y swap thing. So if you want, you can go, but if I'm asking for the inverse when x is 5, isn't this the same thing as the regular, not the inverse, instead of x is 5, equals 5. So it's the same thing as saying find x for g at x equals 5. This is a little harder to picture, so if you're liking this, then just go with this. Okay? Next year in advanced functions, we encourage you more to do it this way, but it's after a year of kind of practicing it and getting used to it. So if you're like, I love this way, I get it, okay, I can sub in, just do this. Okay, and then next year we try to go with, okay, let's see if we can get a different way and a faster way to do it. But for this year, if you're like, I want to just get used to inverse, stick with this, it's good. Okay, so this is wonderful, good way. And if you're like, okay, but I get that it's backwards, I like the way it's backwards, then you can do it this way as well. So that means you would take your original, put 5 here in the side. You see how I put it in the side? So you put it here and solve for it. So if you're able to picture that, that's good. If you can't, then just stick with the inverse. Find the inverse and sub in. Okay, and then next year we start to go, okay, let's see if we can picture the backwards faster. But again, not till next year. Don't worry if you can't do it this year. So divide both sides by 3. So then I would say, therefore, G inverse, sorry. Okay, it's shorter, but it requires the thinking, the backwards thinking. Yes, question? Yeah.
So would this one work for like the questions we were doing earlier, this new method?
Yeah, no, this is not, yeah. So yeah, whenever you can, if you can do the backwards thing, you can go backwards. Yes, for sure. Yeah. Yeah, so this method will always work. It's just a little harder to see at the beginning that what you're asked for is actually the backwards of the inverse of the original function. Yes?
So what I did was, when you're solving, instead of finding the entire equation, I just
You
plugged
subbed in here? Yeah, it's just, you're kind of doing a halfway point, so it doesn't make sense. Like, how would you explain that? So this way is explaining that I found the inverse and now I'm subbing in. Here you're like, I kind of did my own thing and I halfway subbed in. So it's worse. You'll lose marks for communication because it's like you halfway did something. It doesn't make sense when I'm not following. So you would need like a paragraph on the side explaining what you're doing. Right? Because like you're doing half of this and half of that. So I don't want that. This flows because I'm going, why is this inverse of this inverse at 5 is? Right? So either finish it or don't. One or the other. Don't do a half, right? Because it's kind of a jumble of the two. I want it neater. Okay, so try to put it together into one. Sorry, yeah, question?
How does G, like x equals 5, how does that equal to the inverse of G5?
Yeah, so the inverse at when x is 5, remember x and y switch for inverse?
It's
That
kinda
means
like putting 5 as y.
5 is y, exactly that. So you're switching x and,
You just
so,
have to like write it up.
yeah, so that's why I'm saying y is 5, not x is 5. So I said that, and then that's why I'm solving it that way.
Okay.
Yeah, yep.
So when it's like when you know it's like a nice like straight line reflection, then
Yes.
then you can use that method. Or is it for like
No,
everything?
for anything, any inverse. Yeah, you can use this. The question is for any, is it only for lines? You can use it for any inverse. Yeah, so any inverse, if you do this swap thing, then it will work. Yeah, so that's why. So we can, if you can do that, then that's good. If you're like, okay, like this one, it's longer, but I get it more, then we'll get to this one later. Like in grade 12, I like try to do it a little faster when you can because it saves us a bit of time, right? Okay, good.